Okay, so let's continue with what we started on Wednesday. On Wednesday, we said it's easier to move to vector notation when we calculate velocity and acceleration for a rigid body. Last day, you saw velocity can be calculated by omega cross r, and acceleration, which has normal and tangent, each has a formula. Tangent alpha cross r, and normal is omega cross r. Where this come from? Well, if we move back one step to the original formula that we had, you see V is r omega, AT is r alpha, and AN is r omega squared. If we change them to vectors, which the proof might be in your textbook or might not be, but you don't need to know for this course at least. It's more like for advanced courses in dynamics. Then they're going to turn to this vector form. And to use this vector form, we said it's easier to use x, y, and z. And with x, y, and z, we use the unit vector I, j, and k to indicate which direction we are talking about. And one last thing, last time we said is omega and alpha, they are vectors. Although we talk about rotating something about a point, but in fact, they are rotating about an axis, and that axis is coming out of your screen or your paper, and it's normal to the plane of motion. And that's why they can be either positive, coming out of the screen, like this omega that I'm showing, or coming out of the plane or going into the plane. And we use, like here, omega is 5k, meaning it is rotating positive. And by positive, we means it is counterclockwise. It's an agreement. Counterclockwise, we consider it positive, and clockwise, we consider it negative. The same with alpha. It can be positive or it can be negative. For example, let's say alpha here, this picture that I showed here is, let's call it 2, and it's going to be 2 because it's coming out of the plane or it's rotating. Its direction is in counterclockwise, then it is positive, and we say it is plus 2k. Then if I want to calculate, let's say alpha t, then simply alpha t is going to be 2k cross product of r, which r, we said it is 10j. And using the vector notation, k multiplied by j gave me minus I, so it is minus 20i. And the unit, it is AT, it is going to be meter per s squared. And to calculate AN, so we have omega, it is 5k. We have already calculated V, it is minus 50i. So it's going to give me 250. So what is k multiplied by I? If we look at this diagram, k multiplied by I, it gives me j. And I have a negative from minus 50. So it is then minus 250j. And if we look at the picture, we will see that AN here, it's in fact, it is in negative direction of y, right? Because our axis, again, this is y, this is z, and this is the x-axis. And x, y, and z. And we will see they are all matched, right? Because if I look at AN in this diagram, AN is showing toward the center. And the formula also, it says it is minus 250j. And in fact, it is in accord with what we said before when we easily analyze a circular motion. Let's say here, you guys remember for a circular motion, the normal acceleration is always toward the center, right? So this is all matched with each other. And the same formula here again, if you didn't have V, then you could have used like the initial formula, omega cross R. But keep in mind, always first calculate the one in the bracket, like omega cross R. Then you multiply omega by that one. So this is what we said last day, and moving on then here with a general motion. So if you recall, we had three types of motion: pure translation, which was easy, no omega or anything; pure rotation, what we just saw; and then here is a general motion. I have a rigid body, I draw a line on it, AB, and point A go somewhere with a certain speed, point B with a certain speed. Let's say next moment, if I draw the same line, maybe it's gonna be, let's draw it over here. Maybe B comes here and A over there. So B and A. So this is gonna be then B prime, and this will be A prime. So obviously what we notice is the whole thing is moving, and also this line AB, its angle has changed. So it means there must be a change in the speed. So there is an omega then. All right, because if we draw a line, it's going to change angle. So there is a rotation. To analyze this one, we prefer to set a reference. We can set the reference anywhere, but it's easier to set the reference either at point B or either at point A. So let's set the reference, and there is no difference. For now, let's set the reference at point B. What do I mean by setting a reference? Obviously, it implies that we analyze. Let me draw this guy first. We analyze the motion of this system now with respect to point B. And we call, let's say, this one X and this one Y. But for us, remember, always when we set a reference at a point, a fixed reference at a point, it means we are sitting at that point B, we are not moving, and we are looking at the other point, which is here point A. So the person who is sitting at point B, he see that point A is moving, but obviously this R is constant, right? It's not going to change. AB is on a rigid body. We draw a line on rigid body. So R is not going to change. But A is moving, so what point B is seeing is that A is moving on a circular motion, on a circle, right? In other words, I can visualize, or I can imagine that this is the scenario. Let's draw the same rigid body again. And let's say this is our AB, B, and this is A. So for us, then this reference, so it means we imagine point B is fixed. And A is rotating about it. So this is what we can assume, okay, when we said we have a reference at point B. And guys, I want you to pay good attention here, because this is based on all the calculations that we are going to do. And many times students have difficulty understanding it. What happened? We turn a general motion to a pure rotation, which we can understand it now. How? We just saw it previously. If I have an object, let's say a rigid body, AB, and it is rotating about point B, all I need to do now is simply saying that, okay, my X and Y coordinates are here. This is the X and this is the Y. I have a vector R. Let's call this R now in order to avoid confusion. This is a vector RA, but also we put RA with respect to point B. When we say with respect to a point, it means our reference is at that point. That point is a joint or is a PEng now. So it is RA with respect to point B, okay? Now I can calculate VA with respect to point B because we know how to calculate it. It's gonna be omega cross R. Which R? RA with respect to B. Which omega? So of course the omega that we show for this rigid body. But to make sure that we are not confusing it with any other omega, let's call this one omega AB. Or you can just simply call it omega. Okay, so nothing has changed. The only thing that has changed for this general motion, we set a reference, and then we said when we set a reference for that point, the other point has just a simple circular motion, and we know how to calculate the things for a circular motion, which is like this one. Omega again is a vector, and R also is a vector. Then what about point B? Because we know everything is moving, right? And if you recall from motion and dynamics of particles, we had a formula for relative velocity, which said VA is equal to VB plus VA with respect to point B. And this is all vectors again. So if I know the omega, then it means I can calculate VA with respect to B. And then depends on the question, I can find the relation between VA and VB. Maybe I know VB, then I can calculate VA. Or maybe I know VA, then I can calculate VB. And just to emphasize, there is no, it doesn't make any difference if somebody set the X and Y, the reference at point A. Then this formula, their form is going to change. So instead of VA with respect to B, we are going to have VB with respect to A, which is going to be omega AB, that's the same, cross, but this time RB with respect to A. What is RB with respect to A? So it means this time our reference is at point A, and our vectors is going to be from A to B. Okay. Anyway, so let's remove these so you don't get confused when you read them. And let's see, if you guys don't have any question for this part, let's solve one example and see how we can see all of these in action. We have a four-link mechanism here. And in this four-link mechanism, we know how we know the value for omega CB. And the question asks us, what is the angular velocity for OA, for link 4, if we just number them? We know omega for the horizontal link, we want the omega for the other link. This is the question that we want to answer. I'll let you guys to read the question and make sure you understand it. Then I'm going to solve it step by step. And please pay attention. If you can follow and understand this question, it means you can solve any other problem. Okay. So first of all, as always, visualizing the system and see how it moves. Super easy. It's a 4 links. The one on the top is rotating. So it results in rotation of 2 other links. We have the geometry, the angle, and everything's there. First things first, for each of these links, we need to set a reference. So let's start with the easy one, with the CB. We can set the reference anywhere. I can set the reference here. I can set the reference here, and any direction. But it's wise to set the reference somewhere that we can do our calculation easier. Obviously, in this scenario, maybe the best point to set our reference will be point C. So this is the reference for then this point. We will call them X, Y, or whatever we want. So this is X, this is Y. And I decided to have the horizontal and vertical direction as X and Y. So I have to be consistent. So for link OA, I set my X and Y at point O, but I have to be consistent with the direction. I can change the point, the reference, but I have to be consistent with the direction. So I cannot change X and Y to something else. Always horizontal and vertical for all of the point. So these 2 points, easy, we know. And let's look at AB. Always start with these things to consider. Point B, we know the information for point B. We know it's a speed because we know omega CB. So let's call it a noun point. But point A, we don't know anything about it. We don't know how fast it moves because we don't know omega OA. It is unknown. Always in the problem that in this chapter we solve, there is a point that we know its information and a point that we don't know anything about it. And there should be a link or something that connect these 2 points. This link is A, B, obviously. And I need to set a reference for these A and B. And similarly, my reference can be at A or it can be at B. Let's set it at point A. Or to be consistent with the previous one, the formula that we said, let's set it at point B. Again, it doesn't matter. You have the option. So this is then X and Y that I need for this link AB. So for each link, I have now my reference. Now let's set up our the R, the vectors R that we need. Maybe I use, let's say the color red. Okay, so this is one vector. I'm talking about like the link CB. If I want to calculate the velocity of point B, what is the velocity of point B? It will be omega CB cross R, which R? Let's call this one that we just said R1. R1. Do I know the information? Yes, we do. What is omega CB? So it says it is 5 radian per second. We will look at the picture. It is clockwise. Clockwise, we know it's negative. So minus 5K. And remember, everything has to be in vector notation. What is R1? So it is in X direction, and obviously the length is 6. So it's going to be 6I. Simply, if I do the calculation, it's going to be minus 30. K multiplied by I gave me J. And if you forget this one, maybe somewhere in the corner, draw this one. I'll do it always. I, J, K, and rotating like a clock. So K multiplied by I, you see from this picture, give me J. So that's about VB, easy. What about velocity of point A? Well, velocity of point A is omega OA cross R. Where is R? So I connect O to A, and let's call this one maybe R2. So this is just in order not to confuse them. So R2. Let's see what information we have. Omega OA, I don't know anything about it. I'm not sure if it is positive or no, negative, but in vector notation, I'm sure it is going to be something multiplied by k, right? Omega OA k, but we don't know if it is positive or negative. So then this is a question mark for us. What about R? Do we know R? It seems we do, right? Because we know the length is 4 inches. So then we know this vector has a certain length in X and a certain length in Y direction, which is going to simply be, because we have the angle, is going to be 4 cosine 45 minus I and plus 4 sine 45 J. Be careful, guys, about the positive and negative. See this point, this R2, if I find its component in X and Y, simply you can see in X, it is negative, right? Based on the value that we just choose. So this is 4 cosine 45, and this is 4 sine 45. So let me check chat to see if there is any question. Why VCB is a K direction? So in this picture, if you guys look, where is X? You can see X, you can see Y. Where is Z direction? Z is coming out of your screen, right? Remember from last lecture, we said whenever something is rotating about an axis. And that axis here at point C is coming out of your screen. It is counterclockwise, it is clockwise, and that's why it is negative. Right? I hope it's clear. If it's not, if you go back and check the last lecture, we will set when something is in the plane, we consider rotation in an axis. Okay, good. So this is then VA. If I simplify this VA, what do I get? I get, let's carefully calculate these together. K multiplied by I, K multiplied by I gave me J. So it's going to be then minus the square root of 2 omega OA, I don't know, J. And then I multiply this guy by J, the second one, right? So K multiplied by J give me minus I. So then it's going to be minus square root of 2 omega OA I. Let's double check it to make sure we didn't make any mistake. So if I multiply the first things in the bracket by 4 cosine 45, it gives me K multiplied by I, J, and we have a negative. Then we put that negative there. And then it is J, and then K multiplied by J gives me minus I. So everything is good. Then we successfully found VA, but it is still unknown. We have VA and we found VB. What about the relation between A and B? Let me check chat to make sure that you guys are clear. 2 square root of 2. Oh, you're right, because we have 4 here. Thanks. Okay. Let's put the 2 here, the 2 here. You're right. Forgot about this 4 here. It is 4 cosine 45, which is, gives us a square root of 2 divided by 2, and then it's going to be that. Thank you. So the next relation that we can use is VA is equal to VB plus VA with respect to B. This is where we connect these two together. Let's substitute them and see what we get. What is VA? We just calculated. It is minus 2 square root of 2 omega OA J minus 2 square root of 2 omega OA I equal to. What is VB? We just calculated. It is minus 30J. What about VA with respect to B? Well, we just saw in previous slide that it is omega AB, which we don't know what is its value, but we know it must be either positive or negative in a Z direction, coming out of a screen or going into the screen. So it's going to be then omega AB K multiplied by R A with respect to B. I want you guys to again stop here and check to make sure that you understand this. We are substituting VA, that's easy. VB, that's easy. VA with respect to B, it has a formula. We know it is omega AB cross RA with respect to B, right? This is something that we know. What is omega AB? We don't know. What is its direction? Again, we don't know it's positive or negative, but we know it is K. It is either coming out of a screen or going into the screen. What is RA with respect to B? Let's show it on the picture and see if we can figure it out. So this is RA with respect to B. Remember, we set our reference at point B. So what is this vector? I'm going to stop here, let you guys to think, and then compare the value with mine. While you're doing that, I'm going to find its component in X and Y. So this is what we want to find, RA with respect to B, this vector that I showed here by red. So do you agree that we can easily find this distance? It's going to be 8 cosine 30. And I can easily find this distance, which is 8 sine 30. Okay? And we know where is our reference. It is point B. So let's write it one more time. Plus omega AB K RA with respect to B. So the 8 sine 30, and it is negative. So minus 8 sine 30 I. What about J? It is also negative. Minus 8 cosine 30 J. So see, this is not really difficult. It just requires paying attention and see what is negative, what is positive. And the rest is just simple math, right? You just simply multiply these guys together. Let's do that and see what we would get. Minus 30J plus, now let's carefully calculate this guy. K multiplied by I give me J, and I have a negative. This time, be careful, it is 8. So sine 30 is half. It gives me minus 4 omega AB, which I don't know. K multiplied by I, we just said, gives us J. Right? So I multiply this guy by this guy. Now I'll do it with the other guy. So what we did get, first of all, it's going to be 4 square root of 3 cosine 30 we have. Second, we know k multiplied by j. Look at the picture at the top. K multiplied by j gives us minus I. I have a negative sign there. Then it's going to be positive. Don't forget omega a b. And this is going to be I. Okay. So let's see what we got. And let me write down maybe the equation one more time here. Minus 2 OAI 2 square root of I. How we can use now this equation? Well, let's take a look. We have an equation on the left and on the right. There are I and j. Always the i's must be equal to each other. J must be equal to each other. So this is j. So this is j. So again, I say it one more time. Whatever we have on the left and whatever we have on the right for I, they must be the same. For j, they must be the same. Let's see what we have on the right, on the, sorry, left for the I. Over here, we have this guy for I. And over here, we have this guy. Let's write it down. Minus 2 omega OA must be equal to square root of omega AB. What do we have for J? For J, we have this guy, we have this guy, and we have this guy. Let me write them down. Minus 2 square root of 2 omega OA is equal to minus 30. And what else? 4 omega A B. So let's double check one more time to make sure we haven't done any mistake. So this is something that comes from here for I. And we have only one thing for I there. Okay, so that's good. And for J, we have this guy. So this is this guy. And on the other side, we have minus 30 and we have minus 4 omega AB. So I have 2 unknown and 2 equations. If I solve them, I can find omega AB and I can find omega OA. I happened to solve them before. If my math is correct, or maybe I haven't. No. So I let you guys to find out. Okay. And check the math one more time to make sure that we haven't done any mistakes. Seems we are good. Right. So I let you guys to find these 2 values. Now I'm going to stop to see if you guys have any question. And again, it's important to follow each step that we did here. If you could follow each step here, it means you can solve any other problems because only the shape is going to change. The step is going to be the same. Only these values and these numbers are going to change. I'm going to check chat to see. No, you guys are good. No question? Are we all good? Should I move on to the next slide? Okay, let's move on to the next slide. Now I want to solve the same problem, but not using those equations, using vectors and more like graphical method to solve the same problem. How we proceed with that? Please, for the next 5 minutes, pay careful attention. Then you can write down, of course, later, and make sure that I don't make a mistake. It's all geometry and we want to do it right. So we will start looking at the problem, and then obviously we know that our focus should be point B and point A. And of course, point A with respect to point B. This is something that we know. Looking at this problem, it's clear that point B has a velocity, and obviously the direction of the velocity is on this line at this moment, right? Remember, we solved the problem for just this moment. The next moment, things are going to change. So at this moment, we know the information for VB. So this is VB, and we know how much it is. It is 6 multiplied by omega, which is 5, is 30 inch per second. Okay, so forget the I and J and K, because now we just show it graphically that it's coming down, it's on a vertical line. It is R multiplied by omega, we know R, so it is going to be 30. It's inconsistent with what we said before, right here. It is minus 30J. Minus 30J, it means is a vector coming down in Y direction. So what do I know about point A? The only information that I know about point A, its velocity, is that it has to be on this line. Right? This is the only things that we know. It has to be perpendicular to this line. But we don't know if it is to the left or to the right. Why it has to be on this line? Because it's on a circular motion, right? It is on a circular motion. It's rotating about point O on a circular motion. And we know when something is rotating on a circular motion, the velocity is always tangent. And tangent at this point O means being perpendicular to OA. I hope so far we are all good. So let me get rid of this line. Because it's going to be messy soon. And this one we already know it is 90 degrees. And not to forget, let's just write here, VA must be on this line. What about VA with respect to point B? I want you to tell me, what do we know about VA when we compare it with respect to point B? We just said point A has a velocity when we compare it with point O, right? A fixed point. But what about VA with respect to point B? What is its direction? You need to think back about what we said at the very beginning of the lecture. When we say point A with respect to point B, it means we imagine that we fix point B. It's more like a pin, and we are comparing point A with point B. So we think that point A is moving on a circle. Therefore, its velocity is going to be, if I can, let's do that way. So, and its velocity, it has to be perpendicular to line AB. So like this angle is 90 degrees. I'm going to write down here, VA with respect to point B must be on this line. So this is all the information that we have. We know VB, we know its direction, we know VA must be on this blue line, and we know VA with respect to B must be on this red line. This is all the stuff that we know. Now our job is to make a triangle with these three lines. Let's do that. Of course, we start with the one that we know, which is VB. Okay, this is VB. And we'd better to set a scale. Let's say if VB is 30 here, inch per second, maybe I draw a vector with the length of 1 inch. Okay, with my ruler, I draw a line of 1 inch to represent carefully 30 inch per second. So this is 30. And then I have two other lines. And as I said, we need to make a triangle with them. And again, it doesn't matter which is which. So to do a good job, let's draw a line here. Maybe a little longer. Okay. And then the red one, let's carefully draw it over here. So let's see what I did. I made a triangle with these three lines that we know for VB, VA, and VA with respect to B. Okay. And the only things that we know is since VB is noun, we just draw a certain length. Maybe we draw a line of 1 inch or 2 inch or 10 centimeter, doesn't matter. But we said whatever we see on this picture is 30. Now, let's go back and look at the relation that we had in a vector notation. We know that VA must be equal to VB plus VA with respect to B. And geometrically, we know what it means. It means, let's say, if I start from a point, okay, we are almost done, and I want you guys to please pay careful attention. So geometrically for us, like this notation, when we said VA is equal to VB plus VA with respect to B, it means if I start at a certain point, let's say if I start at point here, and whatever, let's say this is VB, I add this guy to VA with respect to B, any vector, it can be anything. I just draw random things. So this is VA with respect to B. So it means when I add VB to VA with respect to B, I'm going to get a vector, which is sum of these two. And again, I start from the same point. So I start from here and I end it here. It doesn't matter if I go from B and then I add VAB to B, or I just go straight VA, this guy, right? And I'm sure you remember this from somewhere in math or physics somewhere. So if that's the case, then how can we draw? This is our 10 main things. How we can draw the vectors on this triangle that we draw about to make sense. If this is VB, which is equal to 30, then definitely we can figure out that, let me find another color. This guy must be the direction for VA with respect to B. Oh, sorry, this is VA. My mistake. Let's move back. Okay, we're trying to make this guy, right? We have VB, and now I need VA with respect to B. So, okay. And we know VA with respect to B must be on this line. So for us, this relation, in order for this relation to make sense, then the only way has to be like that. And then what about VA? VA, we know it must be on this blue line, but this relation can only make sense is if VA is in this direction. Right? Let's take a look and see if things make sense. So our relation says this VA, the one that I write here, right? So let me write it down again here. We want to get to VA equal to VB plus VA with respect to B. So I have VAB plus VB, like this side. And it doesn't matter which one is first, which one is second, right? It's just a plus. So this guy plus this guy, the green, VA plus B, plus this red, VB, give me VA, the pink one, right? So the relation makes sense. And this is what we get. Now, so what? We draw this nice picture. How can we use this nice picture? Two ways. One way, old school, old engineer, when they didn't have their calculators and life was simpler, so they just used their ruler. They said, well, if I know VB is 30, and if I put my ruler here and I measure this distance, and it is, let's say, 2 inches, now I can use my ruler to measure the distance from this point to this point. And then I use the scale. For example, if let's say from like VA with respect to B, the length of this triangle, the side of this triangle is ½ inch. So immediately we say, then it's going to be 15 inches per second. And the same for VA. So that method one is just pure graphic. We use our ruler and geometry and we measure the length by our ruler. And then we use the scale that we used. Or we can use like a grid paper similar to what I have. Another way which I want you guys to use in your exam and in your assignment, in addition to the geometry and using your ruler, just to compare the answer and make sure that you haven't done a mistake, is that in a triangle, we have a bunch of angles as well. Let's find those angles. So I know this angle must be 45. Why? Let's look back at over here. If I have 45 here, then it means this guy has to be 45 because this is 90. And then the red line here, it is 90 degrees, but if I draw another triangle here, this angle is 60. So you guys can try later. This angle has to be 60 degrees. So I have a triangle. I know the angle over there is 60. The angle is just 45. If you get confused, all you need to do is draw maybe another line here parallel to the previous one. And then look at the angle between, like, look at this 30, and then immediately you can say it is 60 over here, right? And we know these two red lines, they are parallel. So if I know this 60, this 40, it has to be 75. We are almost done, guys. One more minute. So let's see. I have a triangle. I know one side and I know the angles. So which relation we should use to find the other two sides? You can type it in the chat. You just can call the relation. If you recall, 2 previous sessions we talked about it. It was right after your midterm. The law of something. Let me check chat. Yep, sine rule. So exactly, law of sine. So what was the law of sine? Simply a relation like that. On the top, we have the sides 30 VA and VA with respect to B. Here, sine 75, sine VA is 60, and sine VA with respect to B, 45. What we get here, we can get VA, and we could get VA with respect to B. So I have VA now. So if I have VA, we know VA is equal to 4 multiplied by omega OA. Remember, we were looking after finding these omega OA, right? For this link. What is omega? What is the velocity of point A? It is the length of the circle or the radius of the circle, which is 4 multiplied by omega A. If I find VA, then I can find omega OA. Done. Please solve this problem, continue this problem, do it one more time, compare the result that you get from previous method, like this guy and this guy. In your exam, you're going to see a problem that I'm asking you to find the answer basically using 2 methods or 3 methods. To summarize, what are the 3 methods? Pure math, IJK formulas, then finding triangle, drawing the vectors and use your ruler and just geometrically measure the length. And what else? Using like a geometrical law of sine or law of cosine or something else to figuring out the side that you want to find. So we are done, guys, for today. I'm going to solve the next example, next lecture, which is after your reading break, just for a quick review of what you learned. Don't forget you have a quiz tomorrow. That quiz is going to be on degree of freedom, super simple. And then at the end of reading break, so the week, like not this weekend, the weekend after, also you have another quiz, which that quiz is going to be on the material we covered today. But it will be a very, very simple problem. Maybe something very similar to example 2. Or maybe something similar to this example, but different values or different shape of a 4-link. Okay, with that note, let me stop recording.